Welcome everyone. I'm so excited to be the host of this fantastic panel. Today we will deep dive into some most exciting and development in the AI and the data infra. So before jumping to the serious part, let me start it with the quick introduction. And I have one requirement when you're doing the introduction is plus with a question. Are you have seen any interesting AI application besides you are using every day besides ChatGPT? Okay, started from Yangqing.
Hi everyone, it's great to be here. This is well, we're basically like the barrier between you and dinner, so we'll be entertaining. Hopefully, my name is Yan Chen. I'm actually doing a company called GenAI, and similar to databases being fundamental in understanding and using data, we basically aim to provide the modern infrastructure or software layer, allowing you to do to acquire GPU resources at half of the price of hyperscalers, allowing you to actually do distributed training and inference with 1/10 of the failure rate that you might encounter with raw GPUs, and helping you to run inference, all those large language models and AIGC at 3 to 5 times more efficiency. And I kind of basically started doing deep learning back at Berkeley, and then hopped around Google, Facebook, Alibaba, and things like that, and finally realized that actually it's more fun and more poor and more interesting to do a startup. In terms of the apps, I think, well, I definitely do ChatGPT every day. And the other one I think I use quite often is GitHub Copilot and RAG kind of thing. So Perplexity and Kimi in China and U.com and those kind of things. I just like dab all of them and basically try to see what works the best.
Okay, cool. Sanjay.
Thank you. My name is Sanjay Misra. I'm the head of product management for Microsoft SQL, Azure SQL, and SQL Server. Awesome to be here. You asked about, other than ChatGPT, what do I use? I use a lot Microsoft Copilot.
Oh, Copilot, yeah.
Every product in Microsoft now has an AI assistant, whether fixing my typos in Word or email, or about converting my Word document into a PowerPoint, which I use, by the way, for my session today. I do use them a lot. So very helpful.
Ooh.
Awesome. So my name is Gu, and I am the head of DevRel at DeFi.ai. And for those of you who don't know us, we are an open source application building platform for generative AI applications. And we're on GitHub, and we have, I think, around 45,000 stars or so by this point. So yeah, definitely feel free to check us out and leave us some feedbacks. And in terms of the applications I use daily, I think Cursor would definitely be a boring answer. And a little more unconventional answer would be an app I use daily, actually, called MyMind. So it's spelled MYMIND. And it's kind of, right. Have you heard of it?
Sorry, M-I something?
MyMind, so MYMIND.
My mind.
I thought you were talking about your mind, actually.
Yeah,
That's interesting.
Their kind of, I guess, goal is to be, like an extension of your mind, right? And what you do is basically, I think the closer comparison to that would be like Mem. I'm not sure if you use that. Mem or Notion or some sort of like personal knowledge management tool. And what you do with MyMind that's really different is you just save whatever content you find, whether it's like a website, whether it's your notes, whether it's like a bookmark, whether it's music, whether it's a movie, whether it's like a video. You kind of just hit save, and without any kind of organization done to that snippet of knowledge. And what it does is in the background, it probably has some really complex RAG system that kind of extract the information from that piece of knowledge and try to do the linking and tagging for you in the background. And I just found that super useful because I'm not like a super organized person, I guess. But I guess what's really clever about it is that I think it sets your expectation really low, right? So I come in not doing any kind of effort that I personally put in myself. So whatever the AI does for me is kind of like a plus. And so whenever I hit a search button and then I search for a term and then all my music or my related notes for that term appears, it's kind of like a pleasant surprise. So I guess I think that's really clever because it kind of leverages AI's abilities really well. In like an area that's like very fault tolerant to like any mishaps from the AI. So yeah, like I highly recommend it. Like please go check it out.
Ooh,
It's a
yeah,
really great app.
interesting. My personally, besides ChatGPT is, I build a lot of customized AI assistant by myself. So it's basically reading my email and draft the reply, and also because I have a lot of unread email, so I'm thinking maybe using the open API from ChatGPT or other AI vendor to help me to automate all of these things. So yeah, all the data are actually stored in TiDB. So it's also the very typical RAG application. So I want to use this as the lead to my next question. Let's get into RAG. Today we mentioned a lot of times about RAG. This is, I would say, the one of the hottest topic right now. If you want to actually build something useful with LLM, maybe RAG is the direction you should definitely to see. So what are your thoughts about RAG? So is it just embedding or is like so yeah. So what do you think about RAG? I think this question I want to start it with Gu, because DeFi.ai I think is a very popular AI platform, help user building their RAG-based application. So yeah, I want to.
Right, yeah, I think we got into RAG quite early. This is actually before me. So our founders, really saw the power of RAG like last May, right? Like more than a year ago. And then like we were one of, I think, the earliest platforms to ever build RAG into our system. I think the vision at that point was like quite beautiful. You have a really user intuitive interface, and then like they have like a bunch of options they can customize, and RAG would just work. And so today we found that that's not the case, apparently. Oops. And I think right now our attention has been shifted towards making our system more open and accommodating different solutions. And I think for me right now, RAG personally is a crush to the LLM's generation capabilities. And we use it because LLMs simply lack the mechanism to accommodate and assimilate new data as it kind of like executes or give outputs. So yeah, like I definitely do think that RAG is as a whole is waiting for its own kind of ChatGPT moment of some sort. Yeah, that would be my take on it.
Cool. Shenzhen?
So LLM is saying, help me help you. And how do we help the LLM to help us? Is providing it a contextual data. So augment is the keyword. In the RAG, augment is the keyword. And we'll be augmenting in many different ways, and these will be evolutions of how these patterns are evolving. Today I was showing a demo of how we are using our own business data to provide that context to the LLM in a RAG framework to be able to get a much more useful, productive, and actionable outcome. So now how these things are going to evolve in many different ways. Good thing is that relational databases where most of the business data is being stored are capable of augmenting the RAG workflow through other kind of a relational filters, inequality, equality, geospatial filters, and all these things that you can put. What we're also finding is that the data have interrelationship between them, and that the database knows about it provided you have a graph capability. So people are building knowledge graphs based on their data and then augmenting the RAG through graph. So these are the many different ways. The augmentation is the keyword. If we kind of focus on augmentation, we'll find many different ways to augment the RAG framework and help LLM help us better.
Interesting. Anshin, what do you think?
Yeah, I definitely agree with Sanjay that A is actually the most important word. And I kind of want to basically like say two things. One is inside RAG and the other one is outside RAG. Inside RAG, I think R is actually way more and actually getting more and more important than generation because you can pretty much plug in any kind of AI model and it works relatively well. Search result is super important, and one of the actually Microsoft senior gentleman who basically ranted at some point to me about, he was like, people seems to have forgotten BM25. And there's a huge amount of dark established knowledge in search, not only just embeddings, but and that's super important. I think gradually people will, after the excitement about just vector search, people will basically start realizing the compositional capability of a conventional AI plus search kind of system. And outside R, I think one most important thing is like augmentation into LLMs is not only just like retrievals, it's actually kind of like all kinds of information that we observe. So you might have noticed that Google kind of put a kind of semi-sneaky feature in Chrome that's basically with the purpose of capturing your interface to the world, right? Yes. If you open Chrome, on the newest Chrome has like this little Google Lens button on your address bar. Click that. It helps you scan the whole web page, and then it just understands the whole web page. This is not only just retrieval, right? It's just like it's an interface in front of the whole the 90% of channel that you get information from, right? And I think like basically down the road, generation becomes a standard tool, and whoever has the data, the entry point between us and the world, will be able to use some smart ways to connect that with the LLM interface. And like Sanjay said, LLM is going to be like helping us we're going to be these kind of like entry points will be helping LLMs to help us in some way.
Yeah, the browser extension is a very interesting entry point. I believe in Lepton.ai you have a very interesting side project called Elmo Chat.
It's called Elmo. Elmo is like the Sesame Street character, right? What it does is basically it's a Chrome plugin. It doesn't really invade your life. You read your web pages, and at some point when you get bored and you want to get a summary of that web page, you call Elmo, and it gives you a summary, which is like super neat and convenient. Shows the capability of LLMs when the input is like an accurate representation of what you want to understand in whatever kind of format.
Interesting. So I want to add a question about RAG because RAG is like a technical architecture, but have you seen any real world scenarios that can be using RAG can be very powerful? The real world scenarios or killer scenario for RAG based architecture.
Search is definitely one, but that's been talked about like over and over. I think customer support and customer satisfaction is definitely one direction that we see quite a lot of, especially fine-tuned models plus RAG being super helpful. So you can actually just like look at the customer conversation history, and based on like your fine-tuned results and example databases, you're like, is this customer going to be happy? Should I have our salesperson reach out to convert him or her to a client and things like that? So I think in those places, I think RAG has been like particularly useful.
Cool.
Yeah, go ahead.
So customer support is definitely what I'm seeing evolution of AI assistants for troubleshooting, for performance tuning, for operational intelligence. So those are evolving rapidly. We are all in the database world here. Most of us work in the data area. And we see that troubleshooting complex database systems need tons of skills. And those skills come not only with the knowledge and experience, but also a lot of data. How has been my CPU utilization over the period of time? How has been my I/O distribution over a period of time? How has been the network latency over a period of time? If that data is used to augment the LLM in a nice way, so that you could get a very good response for troubleshooting why my database is running slow.
Oh yeah, system tuning.
Yeah,
man, cool.
Yeah, I think a really common use case that at least we see a lot from our enterprise client is definitely, I guess within like enterprise internal Q&As. So like when like maybe an employee onboards at a new job, then you ideally like want like a knowledge base that's sitting there ready for them to ask any questions. And I think extending from that, I think a really interesting use case would be like an AI kind of scribe maybe within the enterprise that kind of consolidates all of the information for everyone to retrieve at some point. That would be, like super useful because then, like you wouldn't be having meeting conflicts. You can maybe ask like an agent, who's available at what point. So yeah, like I think in the enterprise, like definitely like RAG would be
Cool. I think TiDB.ai is a great example. Just like you mentioned, is knowledge base, and also we use this tool for the customer support. I actually have received a lot of really good feedback from the community. So I think, yeah, I agree. The customer service and the enterprise knowledge base is will be a good case for now as far as we can see now. Okay, today we have the hottest news. OpenAI released the new model 1.0 or oh 01.
Oh, one.
Oh one, oh one, sorry. So that leads to my second question about the LM. LM has come to a long way. There have been a lot of the direction and noise in the market. So what do you think the LM will evolve? So Yangqing?
Yeah, definitely big news. I think it kind of reminds me of the development of CPU chips.
Yeah.
At the very beginning, we're basically looking at nanometer numbers and basically saying, Moore's law says, every 18 months, actually, we're in the Computer History Museum, the transistors numbers going to be doubling and things like that. And I think that basically held for Pentium 1, Pentium 2, Pentium 3, and then Pentium 4 came. And people realized that, like that kind of scale just doesn't work. And instead of basically having single core GPUs or CPUs, then we started putting like multi-cores, like 4 cores, 8 cores today. All those server CPUs have like 192 cores or things like that. But if you look at the frequency and things, it kind of stayed the same, something around 3 gigahertz or something like that, right? And I kind of feel that basically that was the last round of scaling law.
Okay.
Brute force LLM has, I
Yes,
think the scaling law has kind of semi-plateaued. I'm sure there's still juice to be squeezed out, but I think it's kind of like semi-standardized. And now people are thinking about, RL and multi-round and reflections and things like that. Kind of similar to basically you are having a multi-core version of a CPU, right? You have multi-round of LLM basically trying to improve on top of itself and things like that.
The last round for the MOE is
yeah.
MOE also like this pattern. We cannot rely on a single scaling law, but we put multiple expert or small model together to get a better result.
Yeah, that's a good point. I think MOE is like horizontally scaling because it's basically picking. It's still a one-shot model, but it's picking among multiple experts. And if we understand, well, if I understand it correctly, based on the information that we know about O1, it is kind of like a little bit, I guess, vertical scaling or something like that. It's like multiple rounds, and so that could probably even like combine together to get like better quality results in the end.
Okay. What about you, Sanjay?
Yeah, so size is one dimension. The biggest brain among all the species is with sperm whales. So it's the size of the brain if you say the size is big, right? But sperm whales are not ruling the earth, right? So what will happen in every evolution, including technological evolution, is that once we reach some kind of a scale, limits or boundaries or kind of push, that other kind of evolution will happen, is that everything per square inch, per square meter, per body weight, it will become smarter and smarter. So the animals which have the biggest brain to body ratio is dolphin, number one. Second is human. Okay, while one dimension, if you say that's just the large language model, so the bigger the model, the better it will be. That will be one good dimension. But every model inside it will become smarter. It will become more intelligent, more accurate, more capable, and the evolutions will continue.
Ooh. Today all the LLM we are talking about, all of these are using transformer architecture. So I have a feeling the transformer model we are going to hit the limit because the just like Yangxin said, the scaling law is not gonna work in the short period of time. So Do you see the still have some potential in the transformer architecture, or we need to find the new architecture for the next gen LLM? Yangqing? Or
Yeah, I think this is probably some question that's like really hard to answer. And 10 years ago, I was actually doing PhD, so I knew a little bit about models.
Yeah.
And
You had the
today, I've
background to
already
answer
been
this,
in the
yeah.
infra side, right? Yeah, I kind of feel that, well, of course, transformers have been extremely powerful. One thing that I kind of learned from the computer vision days was that normally we don't need models that big. The history of computer vision models was Alex came up in 2012, the AlexNet, which was the very first successful deep learning model of this round of deep learning revolution. The model size was 60 megabytes. And the next year was something around 100 or 200 megabytes models, sorry, million parameters. Depending on the size, it's a little bit bigger on disk. And then the third year, there was a VGGNet, and that was about like 1 gig parameter or something like that. And people believe that if you want to go more and more intelligent in computer vision, your model has to go bigger and bigger. Until the next year, Google came up with what we call the inception model, because you need to go deeper. The inception model was something around 6 million parameters, basically 100-fold smaller than the previous one.
Yes.
So I kind of feel that basically the trend would probably hold in the sense that we will first of all go bigger and bigger to basically explore the boundary, just like without even thinking about cost. How well can we go to squeeze out the information or to basically extract information from the massive amount of training data? And at some point, we're like, okay, let's ship it in the products, right? Let's ship it on even on phones, and then we can basically start, distilling in some way and compressing. And normally, then in the end, that will probably end up a model that's moderate in size. I mean, I don't know what OpenAI's model is, but right now in the open source world, it seems that the most popular model size is something around 70 billion parameters or 70B, which comfortably sits on 2 GPUs or something like that,
Exactly.
and it's kind of like pretty affordable. So I kind of feel that, yeah, I think model size is going to be like staying moderate and not crazily big, although there are always going to be extremely big models, just like big rockets going to the moon, right?
Ooh, insightful. And let's shift our topic to data. With the rise of Gen AI and all the AI application, I think the challenge rise in the increasing need to handle multimodality data or unstructured data. So, what do you think about what do you think about this trend and also this rise of AI needs to the existing data infrastructure like database, data platform? What will change? Sanjay, you first.
So data is the key. Data is the secret sauce to the AI, right? And what is liquid water to life? Data is to AI. And the multimodal capabilities of using various types of data in a combined way are going to push the AI research in multiple directions. This is related to the previous question
Yes.
that you say, do you think the other type of models is going to? Absolutely.
There are two ways. For example, some vendors say, hey, for different type of data, we need to invent a different type of database or storage solution. Another direction is like, what we are doing is we want to provide a one-stop solution for different type of structured, unstructured, different, pattern like graph, like relational, all in one. So yeah.
Yeah, so what I think, fast forward a bit, you'll have a doctor's office having X-ray image of the patient. From the stetho, they will get the coughing at the voice. They will have your vitals. They will have a video of some other operation, all fit together to a model or with set of models connected through an agentic workflow, and then help them with diagnosis. So the data of multiple nature got from multiple sources, processed through multiple different models, stitched together, will see some evolution in that space.
I think that also depends on, I guess, the extent to which truly multimodal LLMs can evolve, right? Because I think we sort of like got a glimpse or the promise of it from the GPT-4o demo, but right now, I guess we aren't really sure whether that's truly multimodal or not. But yeah, like I guess that will also depend on that. What do you guys think?
True. What about you?
Yeah, I'll probably talk about something that's like completely technical. My last job was actually supporting big data and AI in Alibaba, and honestly speaking, I don't know too much about the internals of big data. I was actually more of the product manager over there. And there was this term, or there was like database and data warehouses, right? And at some point, there was this term started coming up called data lake.
Oh, yeah.
And then I was like, shoot, what is a data lake? File system. It's a POSIX file system. It's a bunch of folders and files, right? And we coined up the term data lake because it sounds more fancy. And AI came and it was even more so like that. So AI is, well, what do AI data, right? It's a bunch of text files which could probably be put in MongoDB or things like that, but that's just like text files in the end. There's multimedia content, images, videos, and things like that. There's like fairly and squarely just, files on a disk, right? And as a result, what we are seeing is a rekindled interest in general purpose file systems and general purpose storage in purpose-built or like GPU clusters. So you might have heard about decade-old company names, like IBM has one called GPFS, a product.
Yes.
There is Vast Data, there is DDN, and there's Weka. If you actually joined an NVIDIA GTC this year, Weka has this like really bright purple, shiny kind of like race car in front of the GTC conference and driving you around town for some reason. Those kind of companies used to be really popular in the high performance computation or HPC and scientific computation days. And when internet came, but they didn't die, they just disappeared in favor of all those, like structured data and things like that. But today they're having a comeback. And a lot of the AI companies, especially those multimedia companies or multimodal companies, are actually in need of a general purpose file system inside the GPU cluster. So I think we're going to be seeing structured data and unstructured data, or basically a glorified file system, existing together because, when people are like really pro unstructured data, they were like, shoot, we actually still need to store some metadata and in need of a RDBMS, right? We're actually in dire need of this is not an advertisement, but we're in dire need of integration with TiDB so that we can have an RDBMS together with the GPU compute and stuff like that. So it's going to be a very nicely coexisting kind of relationship. And we definitely see a rekindled interest of the fancy data lake stuff.
Thank you very much for promoting TiDB. And my 2 cents on this question too is, in the old days when we are talking about unstructured data, picture, video, and audio files, we still need to have some infrastructure to store all of this. Like S3 blob storage, distributed file system. The only gap for this kind of unstructured data we can processing is we cannot build index for this kind of unstructured data. But I think the the vector, the embedding create a bridge between the structured world and the unstructured world, so that all in all, in the end, it is still structured data. But now we can build index, semantic index via embedding for the unstructured data. So that's the power of the LLM, and the bring to the data infra and the database world. So yeah, cool. So next question is about cloud. So we talk about database, talk about data technology. Another big infrastructure today is cloud. I think today the rising of LLM definitely will have some change in the big cloud vendor, public cloud. So I want to hear what do you think about the AI, the rise of the AI impact on the cloud? Yeah.
Thank you.
Azure.
Yes. AI is compute hogging technology, right? So is many technologies. What we'll see is that definitely this is going to influence the evolution of hardware in the infrastructure that are used in the cloud. Many new hardware, storage, networking improvements we can definitely anticipate. We will anticipate how these things are packed together, how these things communicate with each other, network latency, the storage access speed, because AI need tons of data to be able to train, and then how we are able to access that data will determine the speed of evolution of the models. So this will going to put a positive pressure on cloud infrastructure evolution, and I'm very hopeful that this will be good for all.
You know, I remember in the early days when AWS became more and more popular because of the virtualization. But for example, like EC2 is like a great example that you know, virtualization can bring the elasticity on for the you know, modern cloud computing. We are not just selling the metal box, right? So I'm not seeing, is there any similar, you know, virtualization thing happening the, you know, AI cloud or the GPU part?
Good question. Yeah, I think, you know, like there's definite differences in training and inference. In training, we're seeing little to almost no virtualization, because the virtualization idea is I take like a 200 core big CPU machine, cut it down to little pieces and run microservices on there, right? Training today involves tens or hundreds or even thousands of GPU boxes, all very fast connected and things like that. And virtualization doesn't help too much, and only add in overhead. So basically, we are actually seeing bare metal machines connected with really high performance Ethernet or InfiniBand network and things like that. So over there, it's a huge beast. There's literally no virtualization today for training. Inference is kind of different. Now, if you want to basically serve really huge models, then it's kind of similar to training because it involves distributed inference and things like that as well. But there are a lot of medium-sized kind of models or even very small-sized models, right? So I was actually doing some calculation. Imagine if I want an OpenAI Whisper kind of model that basically listens to the things that I talk about and things like that, listens to our conversations, and then basically transcribes those into text as a personal assistant. The computation power is something around 1/3 of an A10 GPU. So not too expensive, which is good news, because maybe one day it gets even cheaper and everyone has a free assistant, right?
Yep.
But that basically means that we actually also need to, you know, like do virtualization when we have like a larger and larger amount of these smaller models in production. We are actually developing something called fractional GPUs, basically being able to actually cut down the GPU memory, the GPU computation into smaller pieces, so that we can actually smash more AI compute into the poor GPU that's way too expensive, right? So I think, you know, like virtualization helps. Probably a slightly different kind of fashion of virtualization, not exactly like the KVM and things like that we used to be, but the concept of basically breaking down one big chunk of stuff and helping it to basically reliably, stably, and in a high performance kind of fashion serve in different workloads still holds, I think.
Okay. And I want to hear the DeFi. You're actually running your platform on public cloud, right? Today.
Yes, we're running this on AWS in the States, actually.
Do you
Not
have
Azure?
Azure?
Come again?
Not Azure.
Why not Azure?
Why not Azure?
Okay.
We'll switch.
We are, yeah, I think when we started out, like the workload is actually quite small, right? So I think Azure is probably much better suited for, you know, bigger workloads. And we were, you know, like starting out really small. So yeah, and we kind of just stuck to AWS.
Okay. That I can.
That was that.
Yeah, I read that like so far so good, but we don't have enough time to consider the scalability problem in the future, right? But I think it's like today if you want to start the startup in AI world, you can, you know, you don't need to buy a lot of GPU or your own data center. You just use the public cloud. So it's like typical route. Okay.
Yeah, and to add to what he said is, and drawing from the virtualization example that you gave, virtualization is nothing but a form of abstraction. People love abstraction. It's easy to communicate, easy to handle, without having to worry about the underneath details. So at different stages of technology evolution, certain form of abstraction works best. So when virtualization came into the picture, there was a certain trend in the technological workload consolidation, workload proliferation, that where the virtualization fit very nicely, and that was it evolved. The AI is a different type of workload, as you said. The abstraction models for AI workload will be different, but there will be some form of abstraction as we kind of grow, expand in this space. And the trend will always be proliferation and then abstraction. So right now we are proliferation stage.
Okay, cool. Yeah, another question is also related to the GPU. Today we can see the Gen AI can be resource intensive pattern. And I actually read a blog by Yang Qing recently. All you need to know about H100, calculate the cost of per token by the generated by LLM. I think, to me, my feeling is the cost today using LLM is still really high. So what do you think about the cost of the interfering or the training in the Gen AI world in the future?
Yeah, it's definitely expensive. Although I think we are kind of like I think we are looking at cost in a kind of like also unrealistically pro-training kind of way. Today, there's a lot of companies who are actually basically still trying to train their foundational models and things like that. Kind of, like if everyone wants to start from scratch, build their own databases, of course, data is going to be expensive. Because why? Because people are actually wasting their time doing repeated stuff, right? And I think down the road, then the foundational models, especially open source ones, are going to be more easy to get access to. You don't really have to retrain your own foundational model and things like that. Similar to today, you can just grab a really nice database to begin with without rebuilding one. And then the bar of entry gets lower. And people will focus more and more on inference or basically building applications. Now, when the need is small, it's always going to be extremely expensive. When the need is large, if there's one thing that this modern society does well, it is optimization. You'll be able to optimize the cost of tokens like very quickly. I mean, over the last 1.5 years, I think we've already seen the per token price to be like 10 times cheaper than at the beginning, right? So imagine in another year, things are going to be another 10 times cheaper. I'm pretty sure that will basically alter a lot of people's thinking process. I mean, for example, GPT 1.0 today, it's basically saying, well, let's do like chain of thought, which was really unrealistically expensive last year, right? It's like, oh, shoot, for one question, I'm going to be spending $10. Well, how about that's going to be like, that becomes 1? How about that becomes 10 cents? How about maybe the year after it becomes 1 cent, right? I can try it. I can try it out. It's no problem. And then I think, like it's going to be a booming industry, and then, like efficiency and also the values out of it is going to be like very prominent.
Awesome. Sanjay and Gu, do you have any comments on the Yang Qing's view?
Yeah, any new technology is always expensive.
At the first time?
I recall 20 years back, all of us used those flat screen monitors. A 24-inch flat screen monitor was $3,500.
Oh my God.
Right? And I said, I cannot afford it, I'm going to run away. But today, if you see, they're not that expensive, right? So he gave a very good example. In last year or so, 90% reduction in the prices for the per token prices. So as the technology becomes more popular, more use cases, more applications, more people will build it, and as a result, it will become cheaper, more accessible, and then it will go like that. So I'm very, very hopeful that this. Don't be worried by the current pricing. It will come to a stage where it will be affordable.
Cool. Okay. My next question is actually about the new concept called responsible AI, and I think it is becoming more and more important because we actually want to use AI in the border or the more and more use case, and some use cases are very mission critical. So I think that will be the emerging problem we need to solve. Or I want to hear your view about responsible AI.
Yeah, I think that's definitely one of the most important topics. I think like for us at DeFi, we definitely have considerations for like moderating AI output since day one. And we have a really great integration of moderation capabilities for all sorts of different models that you can use with DeFi. And yeah, I think as time goes on, like this only becomes ever more critical, right? Even with the new, I think GPT 1.0 model. I think in their announcement, they also said that like they're upgrading like their security measures and moderation capabilities. So yeah, I think as models develop, as they continue to evolve, I I am hopeful though that like these attentions that we put into the system will keep up with the model's capabilities and we can keep them kind of at bay securely. Yeah, that's my.
Okay. Sensei, what do you think for the large enterprise?
I always love analogies. The surgeon has a knife, and he or she uses it to save lives. And a serial killer also has a knife, and you know what they use it for, right? So it is the responsible AI lies on both sides, the builder of the tool and the user of the tool. It's a joint process. Just putting lanes on a highway does not make it safe unless the drivers stay on their lane. So it's super important for the builders of the technology as well as users of the technology to use them in a responsible way. For example, in Microsoft, we have a very, very strict practices around making every single step in software development lifecycle absolutely responsible AI. There are checks and balances in place to ensure that we use the data responsibly, we use our own practices responsibly, our release cycles, everything is done in a, so we call it Microsoft runs on trust. So that's where trustworthy AI, responsible AI is the sustainable AI. And therefore, we all need to be in the on that line.
Is there any technology or technical approach to make sure all this security safety can work on the LLM for the responsible AI?
I think there is actually, and probably it's getting easier than before. So back in the Alibaba days, and also I think like every big cloud provider actually has one product which is like content security, right? Any kind of content you can basically pass through that checker and see if that is offensive content or things like that. Now back then it was really difficult to build a classifier, and it's really difficult to adapt to different kind of like community rules or guidelines or things like that. So imagine, well, I mean, not to name specific forums and things like that, there are a lot of forums on the internet, right? And each forum will basically have their guidelines. In our community, please follow these kind of behavioral suggestions, recommendations or things. And it's really difficult to basically build a personalized moderator, automatic moderator for that. With LLMs, it actually gets much easier, and I know that there are some, community and things actually basically employing the LLMs to basically, like automatically check people's comments and things like that, and politely point out whether when something is actually not conforming to the community rule. The good thing about LLMs and AI is that now these kind of community guidelines could actually be personalized,
yeah,
right?
personalized.
And can be described in natural languages. Like I was actually a moderator in my bulletin board system back in my university. I couldn't imagine basically building a classifier myself, but I can write English. So I think AI and LLMs is actually like, as long as it's used in a good way, it's going to be actually steering the community towards a positive direction. The technology itself is just unbiased, right? So it's all about like how we use it. I mean, we can use it for malicious purposes, and that's going to be tricky. And I think it's the public sector, it's the regulators who should think about how to actually control those kinds of things, and also in a post-mortem basis, hopefully, because we actually do want to promote the development of technology. For companies like Lepton and other kind of companies, we basically aim to provide tools for people to build beneficial tools as easy as possible, because I think in that way people can better understand the tools and can better use the tools.
Cool, very insightful. Okay, perfect timing. So yeah, it's like thank you for all the insights, and we have been a really great conversation. And as the as the ending, I wish everyone can have a one sentence about your hot takes on AI and the data as the for the closing. Yeah.
And data.
AI, data, anything you want to say, one sentence, your hot take.
Ooh, I'm not sure if this is a hot take, but I guess my hot take would be transformers cannot reach AGI.
Okay.
Yeah.
It's like bold guess. Okay, cool. What about you, Sanjay?
That's a very hot take.
Yeah, data is the key to AI. So use data to empower your AI, to empower your tools, but use all of them responsibly.
I think I'm an infra guy, so I think my prediction is going to be like AI and data both will be 10 times faster, 10 times cheaper, and there's going to be like 10 times more applications. And yeah, next year I look forward to come and basically finding that TiDB now has a new name called TAIDB maybe.
Yeah, true. You know, me too. I'm also the database guy, so I think in the end, today's AI application in the end will be the data driven, and data infrastructure will play a very important role in the modern AI application. So yeah, okay, let's call it the good final. Okay,
Thanks so much.
thank you. Enjoy the happy hour.